Hi there, welcome back to the DevOl. I am Roman and this is the 10th and already last episode of our F-sharp introductory series. The last episode ended with a crash. Our whole program crashed because we had a list and we were sure to find an entry in this list, but the program couldn't find one. This is a situation in which you can find yourself quite often when you're doing your programming job. So you have null pointer exceptions, null reference exceptions, something that was expected to be there was just not there. And I think F Sharp has a really nice way to cope with those problems, to completely eradicate them, and this is the option type. So, los geht's! Okay, just to make sure we are all on the same page. So we finished with this key not found exception down here. And the reason was that we are trying to find one entry of the on sales list, which is sales of all flavors that are on sale on a specific weekday. And we are trying to find an entry out of this list based on one given ice sold. So in our case, we had the strawberry, which was sold on Monday, but there was no entry in our on sales list for a strawberry on Monday. And that's why our program crashed. So how does F Sharp cope with these kind of problems? I said there is a nice solution for it. So what's the solution? The solution is the option type in F Sharp. The option type is a special type that has its own module in the standard library and that you can work with pretty easily. So how is this actually done? I think the best way to do this, to explain this, is to actually implement the option type for you. It's not too hard. So the option type is actually a discriminated union. And it's called option. And it has a type parameter. I will come back to this in a second. And this option, this discriminated union consists of two cases. The first one is sum of this type parameter, and the second one is none. So now at every place where we are working with this kind of type with an option, we need to actually unwrap those cases with pattern matching, as I've showed you earlier, and we need to acknowledge the fact that it can be none. So I just said that the option type has a type parameter. What does it mean? Or what is it good for? It's good for that we can use or we can wrap any type in our option type. And so this is just a variable, and it means that this case of the discriminated union wraps some value. In defining this type, we don't know which value we want to wrap, and therefore we use this type variable. When we have a look up here, we know that our special case in the flavor type wraps a type of a special value, this one here. In this case, we don't know what we want to wrap, and therefore we use this type variable. All right, here we have this option type, and now we said that the exception is not occurring here. It's the list function, the list.find function, that actually throws the exception, that throws the error. The reason is that the find function down here says that it throws a system collection generic key not found exception thrown if the predicate evaluates to false or for all the elements of the list. But we want to change this. We don't want to throw an exception. What we want is that if no value is actually found, we want to return none. And fortunately, this is implemented in F Sharp in a couple of cases, and most of the time it's done with the try prefix for functions. So it means that I don't use the find function here, I use the try find function. So what is the difference here now? It says that it's the same as the find function. We need to enter a predicate which takes some entry and returns a boolean, and we need to give it a list. But in the end, it doesn't give us the actual value. It gives us an option of the value, which means the value wrapped in this option type. And that's the reason why we have this red squiggle here now? Because on sales is now an on sales option. So we don't know if the value is actually there. So how can we actually work with this? How can we actually work with something when we're not sure if it's there or not? Well, we can write a helper function for this. So what do we expect the helper function to do? We want to actually evaluate a function on the value of the option if the value is there. If it's not there, we don't want to do anything. So let's call this function map option because we want to map somehow over the wrapped input. And this function needs a function as the parameter, which is the mapper, the function that we want to work on the input. And we need the actual option. And now we need to match on the option with, if it's sum with some value, then we say call the mapper on the value. And now the question is, what do we do when we get none? So when we have some value in here, we want to call the mapper on this. But in this case, we have no clue what we want to do. So we want to do nothing actually. But what should we return from this function? Well, maybe just another option. So we could return none as well in this case. But in this case, what should we return here? Well, we could just wrap the whole return value of our mapper applied to the wrapped value again in a sum. So now we have a map option function which takes a mapper, which is a function from A to B, sum A to sum B, and which takes an option of some value, and with the help of the mapper, it returns an option of some other value. So this function only applies the mapper to the value only if there is a value. If there is no value at all, we don't do anything with this none value. All right, let's make this useful now. So what do we want to have? We want to get the factor out of an on sale, which is now an option, so it's not possible anymore. So let's introduce a new identifier called factor. And this is the place where we want to extract the value out of the option. So let's do this. We take the on sale, and now we pipe this on sale into our map option helper function. And this function takes a mapper, which is a function, and here we get the actual on sale value because this function is only called when the option actually wraps a type, so has a type in it. So we say on sale, and what we want to return here is on sale dot factor. So this is not working because we have this option type in here, and it's a bit different option type than the F# option type, obviously, because it's defined somewhere else. So we delete this here, and now we get a factor out of the on sale. So we can put the factor in here. But wait, it's still not working. Why? Why is it not working? Oh well, because the factor is still an option. Because what we have done is only we applied a mapper to the option type, to the optional on sale, and we applied a mapper function that extracted the factor, but only if it has actually done something. Otherwise, it would have just returned none. And in the case that it was actually applied, it wrapped the return value again in a sum. But the question is, how do we get this value now out of the option? Because we can't just grab in there and say, give me the value. I know there is some value in there. Then we wouldn't have, there would be no need to do this in the first place, because then we are in the same position as before, that we could have runtime exceptions, null pointer exceptions, etc. So we need a function that gives us the value if it's in there. And if it's not in there, this function could just give us a default value. So for example, in this case, what would be the default value if there is no ice, or if this ice is not on sale for this specific day? Well, the default value could just be 1.0, because then this calculation would return the same result if we would just say 1.0, of course. Let's do this. We need to define a new function. Let default option. This function gets a default value and this option. And in here we say match option with some value. And when we have a value, we want to return this value and not wrapped anymore, because we want to work with the actual value. If we don't have anything, what should we return? Well, we should return the default value. And now we can pipe this result into our default option function. And the default value of the function is 1.0. And now the factor is a float. It's not an option anymore, because we extracted the value out of it, and if there is no value wrapped, we would take the default value 1.0. Nice. But now I can hear you thinking that it's a bit cumbersome to define those functions when the option type is actually in F# ingrained, so it's already implemented in there. Why do we need to implement this map and default functions? Because they might be used very often. And you're right with this. I was just implementing them to show you how the option type actually works. So we can use the option module and say map, and we can use the option module and say default value, which is exactly the same. So these functions are more or less implemented in the same way than as you see them here. So we can delete them, and now we have a nice and safe way to work with values that might not be there all the time. So we can evaluate all our stuff. And we see when we evaluate this function that was throwing an exception in the last episode, we get a value back now, because now there's no way that we get a runtime exception out of this calculation. All right, is there a way to refactor this to make it a bit nicer? I think there is one, because if you have a look in here, the on sale is only used in the next pipeline as the first input to map over it and get the value out of the option. So we don't need this at all. We could just say we don't need the on sale value. So we could just cut this, put this in here, and have a nice pipeline to get out the factor for our on sales list. We enter our on sales list, try to find the actual fitting value. If it's there, get out the factor out of this value, and if it's not there, use the default value 1.0. Whew, that's it. We have done it. You have done it. This marks the end of the F# introductory series. I think we have covered a lot. We've started with the values, value bindings, names, identifiers, functions, function composition, records, discriminated union, partial application, currying, and the option type in the end. And I think we've covered quite a lot of ground. This was quite an adventure. At least it was quite a big adventure for me. I have never done anything like this before. It was a lot of work, much more work than expected, but I enjoyed the process of doing this. I learned a lot for myself. So if you have any questions, any comments, please feel free to leave them here. Contact me on Twitter if you like. And if you want to see anything else, have ideas for new episodes, also please contact me. I have a lot of stuff in my head, but a lot that I want to cover and a lot I want to do. But for now, that's it. And I hope to see you in the future. Bye bye. See you next time.